We are still working with polynomials, and this is going to be review problem number 8. And in this case, my polynomial is x cubed plus 3x squared minus x minus 3. And the first thing we want to ask is, what is the degree? And again, for most of these, I'm just going to look at my leading coefficient in my dominant term here, which is my x cubed term. So here my degree is going to be 3. My leading coefficient will be a 1. And we can assume there's a 1 there in front of those, in front of that x cubed. Our end behavior, okay, this is going to be the same as problem number 7. We're only going to think about this as, hey, what is y equals x cubed doing? And when x is a big negative number, y is going to be a big negative number. So this is going to be negative infinity. And as x is positive, there's nothing here to make y negative. Again, if x is positive, we cube it, it's positive. We don't change the sign with our leading coefficient. And so this would be positive infinity. Okay, the max number of real roots, that's always going to be our degree. And we can have a maximum of 3. We may have a couple imaginary, but we have a maximum number of 3 that could be there. The maximum number of complex or imaginary roots, again, they come in pairs. So the most I could have with a third degree polynomial is 2. Max turning points, that would be if I have something like this, a cube, I can have 2 turning points. The y-intercept in this case, we know if x is 0, then our y-intercept is going to be -3. So in this case, it's going to be -3. Okay, all of our possible rational roots, and this would be if we were going to use the factor theorem to factor and solve this problem or find our roots. But in this case, let's look at this. So our last term here is, let me erase some of this up here. And this is 3. Okay, so our in term here, plus or minus 1 and plus or minus 3 are the factors of 3. And then out front, which is nice, I just have a 1 coefficient, so it's just going to be plus or minus 1. And then, so my possible rational roots will be plus or minus 1 over 1. And plus or minus 3 over 1. And that's just going to be the same thing as, we can think of this as plus or minus 1 or plus or minus 3. Okay, so I could try these numbers in my polynomial and see if I get a 0. And that would tell me those are roots. But in this case, I may not have to do that. Again, this is something we can try on any polynomial. We can try plugging these in and see if we can find a factor. And say if we found 1 works, then we would know x minus 1 is probably a factor, and we could do some division and figure out what the other factors were. But we also have, with cubics, we have some special cases. And one of those special cases would be an equation that we can try and factor by grouping. So let's try that in this case. So we know I've got, let's go to white here. I've got f of x equals x cubed plus 3x squared minus x minus 3. And when we're trying to find the roots or the x-intercepts, right, we are trying to find out where f of x equals 0. Again, if I graph this, then anywhere f of x, which is our y value, anywhere it crosses the x-axis, y is going to be 0. Okay, so we know this polynomial isn't going to look quite like that, but just to throw that out there. Okay. So one thing we can do when we have a cubic, we can try factor by grouping. And when we do that, we're going to try and factor these 2 terms and then see if we can factor those 2 terms. So let's try that and see if we get something that might work. So I'm going to look at these first two terms, and I would have an x cubed in common. And then if I factor out an x squared, or I have an x squared in common, if I factor out that x squared, I'm going to get an x plus 3. And again, if we multiplied this back out, if I distributed this back out, we would get to back where we started. And then here I can see these two terms, these second two terms, I have a -1 in common. I'm going to go ahead and write that -1 out there, and then I would have x plus 3. Okay, and that's really nice because that gives us this common term. And now we can think of, I'm going to take another step in factoring and think of this x plus 3 as a common term. So I'm going to factor that out. So I have x plus 3. And what I'm going to have left is x squared minus 1. Okay. Now, again, I'm trying to set all of this equal to 0. So we can see here, hey, if x equals -3, that gives me a 0 here. 0 times whatever this term is will give me a 0 here. Well, I've also got another case here where I can factor this some more. This is a difference of 2 squareds, and that's going to be x plus 1 times x minus 1. Now, if that looks a little like where is that coming from, you can multiply these terms out, these two terms together. You could FOIL those. You'll see that the middle terms fall out, and all I would be left with was x squared minus 1, which is where we started. And so we can see, hey, this is pretty nice because I can just look at these two terms and say, hey, if x equals -1 or if x equals 1, those will give me zeros in those terms and will yield a nice 0 on my f for f of x. Okay, so here, this was a nice factor by grouping, makes this nice and quick. I get 3 roots. I have x equals -3, -1, and 1, and all of those should give me f of x equal to 0. So this is my answer. Okay, I did graph this in Desmos. Let's see if that makes sense. If we graph this, we can see, hey, I do have an answer here at -3, -1, and 1. So let's just go through. -3, -1, and 1 all give us f of x. Again, anytime we cross the x-axis, we know that our f of x term is 0. All right, so do the work and let the answers come to you as you know they will.